Hello, everyone, and welcome to today's session. Thanks so much for being this morning with us. We're going to check really quick that the audio quality is good. Please let us know if the audio is loud and clear. We will be using the question panel on the right side of your screen. There is a question panel where you're going to be able, thank you, Steve. We're going to be using this question panel throughout the webinar. So please send us all of your questions, inquiries. We'll be happy to answer them. Ken, thank you so much. David, audio 5 out of 5. Great, awesome. So we're going to start in about 3 minutes at 10:05. Just waiting for everyone to join in, and please just check your audio, check out the question panel. Please stop us anytime throughout the webinar. We'll be happy to answer all of your questions. Okay, thank you so much, everyone, for being this morning with us. I would like to introduce our today's presenter, Tassos Alexiou from RF Elements. He will be giving us this RF Elements webinar. So this session will be recorded, and by the end of the webinar, you'll be having the link for the recording as well as the presentation. So please send us all of your questions throughout the webinar. And for those just joining in, welcome. And I think now we're ready to start. Tassos, are you ready?
Yep, I'm here.
Awesome. So now you can start.
Excellent. Well, thank you, everybody, for joining us possibly again for our next webinar. My name is, again, Tassos with RF Elements, and today we'll be doing our Migration to Horns 101. So this is a webinar designed to kind of help you understand how you can transition from your current antenna technology over to our horn antennas. So one of the problems, or some of the problems with migrating to horns is that people are sometimes really not sure where to start, right? You've heard about the technology, you've heard other people talk about it, but you're not really sure how to migrate, again, this new technology into your network, because it works quite differently than probably what you're used to. You might also maybe have a unclear migration path, right? You're unsure, do I, rip and replace everything? Is there a step-by-step, process I can go through, and all those other questions you might have, as well as, maybe some initial tests, had really fuzzy results. Like, maybe you try the technology yourself. You've bought some of our antennas, and really, maybe you're not seeing what you expected to see, right? Or maybe it's not performing, or you're not getting the signal you thought. That there's reasons why that may happen. So maybe you've tested it again, you're still unclear, or maybe you're just totally lost. Maybe this is the first time you've heard of RF Elements, and maybe this is the first time you've heard about our horns. And hopefully, again, after we go through this webinar, we should answer some of those questions and hopefully make it more clear. So the question is really, how do you efficiently migrate to this new technology, right? So there's a few different ways, different methods, different approaches to migrate in a efficient way to this new antenna technology. Throughout this webinar, we will look at, following some of the best known customer practices, right? So this is not just, these methodologies are not just something that, came together based on the specs of the antennas, but it's really coming from the user base itself, right? From WISPs that had specific problems and needed to, again, fix specific issues, and the best practices that they use to come up with this like migration path. Also, it's about, solving the problem you actually have, right? So, horns are absolutely fantastic and they help a lot, but, sometimes the approach of WISPs or, for really any industry is to just, again, all out, just replace and do whatever with the latest and greatest. Really, you have to look at what's the problem I'm actually trying to solve. And once you understand what your problem truly is, then you can, again, more efficiently utilize our antenna technology to help you overcome and solve that problem. Another thing is really understanding the spectral limits of your area, right? So not every deployment is the same. Some people might have more available spectrum than others. Again, some might have, a lot more noise, a lot more congestion. So you really have to understand, what your area looks like from the RF perspective, and then that again will feed into helping you decide which of the many different horn antennas that we manufacture would be the right tool for the job. And then finally, use your available spectrum wisely. Something that you will find is that, more spectrum is generally available to you when you look at your spectrum through one of our horns because of all the noise rejection. So just because you may find 40 or 80 megahertz of concurrent spectrum or channel space, right, you shouldn't just rush to go use it, right? So you should understand, what your limits are and use as much spectrum as you need, right? Because again, it's really a finite resource that you have available to you. So again, use your available spectrum wisely and you'll be able to really migrate to this technology in a more robust way. So the presentation is broken down into two different migration paths. There's really two kind of methods out there. There's the first method we'll talk about as we start is the augmented coverage or the hybrid deployment. And this is basically utilizing horn antennas and your current antenna technology at the same time, right? So we'll go through different methods and how you can use them both as you transition. Of course, the second method is just the full out, new tower build with nothing but horns. And then finally, there'll be a conclusion at the end to kind of recap everything that we talked about. So before we go into these different migration paths or these different methods for rolling out horns throughout your networks, we need to go over a few things. So one of the misconceptions or some of the first thoughts of people is in order to go to horns, you really need to do a network forklift. And really, that's not the case. You don't need to forklift your entire network from the start, take down all your sectors, take all your customers offline for potential long period of downtime. With horn antennas, again, there's a way to migrate where you put up your horns, you slowly transition your customers onto those new horns, and then you decommission your old sector, right, or your old antenna technology. So this planned phased migration path, right, of putting up your new APs and decommissioning your old will practically give you almost zero downtime when you migrate this. So the important thing here is, you shouldn't expect to have long network outages while you retrofit and upgrade your customers as you transition them to horns from your current antenna technology. Another important thing to note is to really know where your customers are, because traditional sectors and patch array sectors are extremely sloppy with large side lobes. Not only do they transmit in much wider angles than the spec 40, 30, 60, 90, whatever sector you may have, but there's also ample side lobes out the back in the side. So you really need to know where your customers are before you transition, because if you were to take down that sector and put up a horn, you unfortunately will find out the ones that were connected to the back that you didn't know about, and so on and so forth. So it's, again, it's important to know so you can take those customers and be prepared to transition them to another AP on your tower or another tower or what have you. So knowing where they are before you migrate will make it more seamless with, again, less downtime, which is the key. You also need to get in the mindset of using the right antenna for their job, right? So, you know, you have to understand, again, going back to where your customers are, right? If you have a lot of customers or your customers are close into the tower, it's really, you know, not advantageous to you to use a really high gain sector with more received gain than you actually need for the distance that you're covering, right? So you could use a wider, lower gain horn antenna to bring those customers in and not send, you know, so much noise further out, and more importantly, not receive noise from further distances when you use more gain that's necessary. And we, again, offer, you know, to date, over 12 different horn styles in different angles and different gains and different beam patterns to help you achieve the right coverage area for the job you're trying to do. The second thing is also, you know, again, when you pick the right antenna, right, you know, you should use it properly as well. So often what you'll see is that operators will use multiple patch array sectors to cover the same exact kind of area, right, or the same exact azimuth, which leads to you overlapping you know, two coverage areas with two different sectors, which is really bad for the AP performance, because you have all those clients facing back in the same direction, blasting the other antenna basically, or your other AP, and therefore creating lots of interference for you, right? So whether you're covering the same entire area with the same down tilt, or maybe you're using two antennas, one with more down tilt for the closing customers, as we see here on the left, and then you know, one with less down tilt for the further out customers. Again, you see a large region of overlap, where if you look on the right-hand side, you know, you should cut up your spectrum if you need capacity or you need to add more AP density, cut it up by azimuth, right? So take that 90-degree area and cut it into 330 degrees, or take that 120-degree sector and cut it into two 60-degree azimuths or something, so you don't have any sector overlap, because again, it creates a lot of problems for you, and you'll end up fighting again, noise issues with from your own device. So again, try not to use multiple sector antennas to cover the same area. You should use, you know, again, the right beam angle and the right gain that gives you precision over your coverage area. Or again, if you need that density and you need that, you know, AP density in your tower, split that azimuth up into multiple different beam angles in order to cover that network. So we like to say, and we see in practice, that a balanced network is really a happy network, right? So if you look at your typical coverage area of a sector, you usually have the customers that are in the center here in white have the highest MCS rates, because it's kind of in the sweet spot. And as you move to the edge of the sector, the performance starts to degrade, because that's truly where the performance starts to degrade, as far as the beams overlapping, the amount of gain towards the edge, you know, the chain 0, chain 1 mismatches start to happen as you get to the edge on the outer sides, and again at the furthest distance. So when you have a very large delta, right, a very large average of different MCS rates on your radio, as you see depicted here, you have customers with MCS 9, you have some customers that are, you know, have somewhere between 7 and 9, and then you finally have the guys on the edges and the fringe of your coverage sector down to 4 and 6. This really creates a huge CPU load on your access point, and therefore really starts to dramatically reduce your network throughput, right? So with horn antennas, right, or specifically our horn antennas, because the vertical and horizontal beams are identical, because the gain dispersed across that coverage area is identical, you will see, again, a more balanced network where the number of different MCS rates throughout your coverage area is much narrower, right? So the CPU isn't spending so much time, you know, doing modulation MCS 9 for customer A, and then going to MCS 4 for customer B, and then back up to 7 for customer C, and back to 9, and so on and so forth. So every time your radio has to stop and switch modulation rates, you're losing airtime, and therefore reducing the total amount of throughput that that radio can put out. So even though you may see on a horn antenna, depending on which one you pick and what your deployment is like, you may see lower MCS rates, right, but they're more stable. This will actually overall give you a much better user experience, lower latencies, and therefore a better customer experience, and so forth. So it's important to understand the difference that you will see in a balanced network on horns versus, you know, traditional sectors. And then finally, you really need to understand your technology. As I mentioned earlier, right, horn antennas are different than anything you've used before, right? The antenna patterns have a totally different shape. The beams themselves in both vertical and horizontal polarity are identical. The gain across the entire spectrum is very flat compared to a traditional sector. So you need to understand how gain rolls off as you go to the edge of your antenna. So here at 0 degrees of down tilt, you had full gain, right? So as you down tilt, you know, up to 20 degrees, or in this case 12 right here, the gain at the horizon is actually only 10 dBi versus the spec of full gain on the bore site of 18 dBi, right? So the same happens as you go to the edge. So again, you know, something that's often misunderstood or misspoken about is the potential lower gain of horn antennas versus sector antennas, but really this perceived weakness that people like to talk about lower gain is really a strength, because you could now make your antennas even more noise immune by not only utilizing the very unique antenna pattern or radiation pattern of our antennas, but if you utilize down tilt and other mechanisms, you can again reduce the impact, and therefore it gives you even more flexibility. So really, again, you need to understand how this antenna technology works in order to see how you can greatly benefit from it, from more things than just the antenna pattern. So now we'll move into the different methodologies. So the first method is that augmented coverage that we spoke about, or I spoke about earlier, where you utilize horn antennas in conjunction at the same time with your traditional sectors or your current antenna technology. So we're going to go through a few different types of augmented coverage, right? So, you know, one will be, you know, possibly used if you're trying to offload oversubscribed APs, or just simply trying to add capacity to your tower, right? We'll talk about the migration path of augmented coverage for maybe using smaller, wider horns for your close-in customers, and maybe using or keeping your traditional sector for further out customers or something like that. You know, you may be using our higher gain, larger, more narrow beam horns for very specific high density deployments. You know, maybe you're just trying to add high throughput packages, you know, with the horns, and keep your low end customers on your sectors. And you know, finally, you know, another method is really utilizing horns in between your sector to improve that edge of sector performance. If you remember earlier in the slide, we talked about a balanced network is a happy network, where your customer, the customers on the outer edge, where your two sectors kind of come together. That's the worst performing area of you know, your antenna. Some customers use horns in between to not have those, you know, edge of sector customers on the sector, but actually on the horn. So we'll talk about, again, you know, those different things. So for offloading capacity, here we see two sectors with red clients that have poor throughput, because it's just clearly oversubscribed, or maybe again there's too many customers towards the edge, whatever the reasoning may be. You just want to offload or add capacity. So again, one of the methods is you can just put up 2 horn antennas, right, in that in part of those 2 overloaded coverage areas, offload those customers onto the horn, which will again bring them into a better throughput. And because now your sector, which was before overloaded or had a large delta possibly of different MCS rates and too many customers, now that it's working less, and it's not working as hard, the other customers that are left on that sector can possibly have a much better user experience, and speeds may come up and lower latency. So that's one way of offloading or adding capacity to your current network. Another method is using smaller, wider horns for close-in customers. So maybe, you have your coverage area, and you notice that you have a large cluster of customers that's, in close to your tower. Maybe you're in a rural area. Maybe your tower is in the middle of town. So, like maybe it's no more than a mile to the edge of town, where you have, a lot more densely populated houses and businesses. But as you go further out from town, this is where it's more sparsely, covered, right, where the customers aren't as close and not as dense. So, perhaps you can segment those guys out by putting up a lower gain, wider horn, symmetrical horn, to bring those customers in to a different AP, and therefore leaving the other customers that are less dense on the sector. So again, this is another potential use case or method that you can look at implemented as you transition to replacing everybody onto horns. Another methodology is again using the larger, narrower, higher gain horns, for high density. So perhaps, this is the converse, the opposite of what we talked previously. So maybe you're covering a rural area where again density is really low, so you're using your sector, but then they come in and they build a little housing complex or some sort of development out somewhere in your coverage area, and now you have a tightly more dense coverage area that you need to service. Again, you can put up one of our more narrow horns, right, and spot beam, as some people like to call it, right, where you focus that energy and point it directly at that spot and put all those customers onto, an access point with a horn, while leaving again the other customers in the less dense areas still on the sector. So that's again another use case for something you can look at on how to use it effectively and how it might help you. Perhaps you just want to sell higher throughput packages with horns to, again, some specific customers, right? So, there's really a difference in the SLAs, the service level agreements, between business customers and home residential customers, right? And it's typically not best to have business customers and residential customers fed off the same sector, because the data patterns and the usage is totally different. So maybe, again, you identify a part in town where there's some business customers, again, just like the housing development that might go up in your rural coverage area. Perhaps you pick out 4 or 5 customers or a small cluster of customers within your coverage area that you can use a more tighter, highly focused, higher gain horn antenna, like our 30-degree symmetrical horn, to go ahead and just put those customers on a new AP for just business class services, while leaving everybody else on the traditional sector, again, with the non-SLA or the lower requirements for speed, throughput, uptime, and other things. So it's another very useful tool to help make your network more healthy. And then finally, improving the edge of sector performance. So again, this is kind of what we talked about in the balanced network, where if you look at your traditional coverage area or traditional sectors, where the sectors overlap, again, is the more poorer performer of the antenna. This is where, again, you usually see those chain mismatch errors. If you've ever looked at your radio and wondered why chain 0 sees a neg 50, right? And chain 1 sees a neg 55. We've seen deltas much higher than that, but as an example, that 4, 5, or maybe 6 dBs of different intensity between chain 0 and chain 1 really reduce your MCS rate. You really require both chain 0 and chain 1 to have no more than 1 to 2 dB of intensity delta in order to maintain the higher MCS rates and stay at a stable MCS rate, which is even more important. So what you can do, again, is perhaps take some of our more narrow horn antennas and shoot them, again, down the center of the coverage area where the two sectors overlap. Again, take those customers, transition them onto the new access point with one of our horns, and then leaving, again, the customers who are in the better, as we say, like sweet spot of a sector, which is typically down the center and not so much towards the edge of the sector. And therefore, everybody will have a much better signal, much better usability. Again, there's less stress once again on those other APs. So therefore, again, there's more airtime to transmit, and therefore you'll have a much better user experience for everybody. So again, this is yet another method that has been used and is really honestly currently being used by many WISPs today still. So, really the kind of conclusion of most of this stuff is really, sectors, using sectors with horns really isn't, the end game, right? Because as long as you have sector antennas on your towers with all of their side lobes overlapping and interfering with your co-located APs on your tower, hearing noise because maybe you're using too much gain for a short distance, you're not going to have really enough channels to maintain this kind of high density deployment with horns and sectors at the same time. So really, in order to see the overall benefit of what your network can really be like and how much throughput and how many customers you can truly add, you won't see that until you replace your entire sector or your entire tower with nothing but horns. Because again, as you start utilizing horns, you will find the ability to deliver the same or higher speeds on a 20 megahertz channel compared to some of the speeds on 40 megahertz channels, again, because of how the antenna patterns work and how uniform the performance is across the entire spectrum. So really, going with nothing but horns should be the end game and how you should really grow your network. So now we'll talk about the second method, which is like building out new towers, or again, just totally redoing your current towers with nothing but horns. So there's only really a few different methods here. They're quite simple to understand. There's basically different 360-degree coverage maps or patterns that you can do with all of our horns, right? So, the one is the uniform coverage. This is where you use, again, the standard geometries, right? Obviously 490s, 660s, 1230s, again, 24, 15-degree ultra horns, whatever it might be. So it's the coverage pattern where you're using the same geometries, the same antennas to give you 360-degree coverage. The second one is, my favorite, which is building custom coverage based on the customer layout with a mix of all of our horns, right? So you may not always need 360-degree coverage. Maybe you only need 270 or 240, right? So you don't always have to build it out with nothing but 30-degree horns. You may have customers, that are going up against a mountain that's only a mile away in one direction. Why put up a really high gain sector antenna that can hear noise through side lobe from different directions when you could use a lower gain one? So there's many different ones. And then there's the kind of adding horns as coverage is needed, right? So we'll go through all these different types of methodologies. So really the uniform coverage is quite simple, right? You have your customer disbursement, so you can put up 6 60-degree horns to cover them. You can put up, again, if it's really high density, you can put up 12 30-degree horns to get the coverage, and obviously any combination kind of in between to build a uniform coverage area based on user density or and maybe you're building it, overbuilding it because you know you don't have that on day one, but you're going to have that on day 100, and might as well put them all up now, whatever it is. But this is the uniform coverage, which is quite simple. Custom coverage, which happens to be my favorite, is again where you use a mix of different horns based on where your customers really are, right? So using a combination of our 30s, 60s, 40s, 50s, 80s, and 90s, right, to build this coverage. And even now today, right, you know, using a mix of symmetrical and asymmetrical horns to again give you the gain and pattern you need based on where your customers are, right? So this is really important when you start building out high density tower deployments, right? So it's one thing to have a high density tower by itself where you have a lot of customers, but if you're going to be putting up towers every few miles because there's just an overload of potential customers, it's really important to think, you know, what antenna gain I have facing my other potential tower, right? So this is also important when you have competition in the area. So if you know where your coverage area is, use the appropriate gain and the right beam angle, and look for the right specs. Again, we make 12 different types or 11 different types of horn antennas to help you mix and match and build the coverage you need for where your customers actually are. And then finally, you know, adding horns as coverage is needed, right? So, you know, perhaps you start with 490-degree horns, right? Because you're covering right in town. And then again, you want to expand and move further out where there's more density. So you just take down one of those 90s and throw up, again, 3 30-degree horns, or you take down, you know, again, 2 90-degree horns for 180 degrees coverage and throw up 360. So this is kind of a custom coverage as well, but it's a kind of build as you go. One of the you know, most questions that we get from customers is, you know, hey, they think they need the highest gain, most narrow, and they say, hey, I can't afford to put up 12 access points and 12 horns to begin with, right? Then really you don't have to, right? You can start small, start with the wider beam angles, and as the density grows, as the customers come in, as your coverage area expands, you can go ahead and replace a lot of those other horns with different horns in order to do it. So that really goes over the different types of coverage areas and the different methodologies, again, that, you know, these methods aren't just something we thought up of and put on paper, like maybe this is how they can use it. This is really coming directly from the user base, right? We kind of put the horns out there. We had our basic idea of what, you know, what can be done and how they can be used, and it was really up to the user base to find different methods and different ways of utilizing them to help benefit the industry as a whole. So really exciting to have really this continuous stream of input from the user base on how they utilize our antenna technology and how they help optimize their own WISPs, and therefore can share that information with other WISPs to help them grow as well. So as we come kind of into the conclusion now, right, we talked about the different methods. The conclusion as we wrap up is to remember, you know, use the correct size horn for your coverage area, right? I can't really stress this enough. You know, again, as an example, our 90-degree symmetrical horn, people often complain that the gain is too low for that antenna, right? It wasn't that we said, let's create, you know, that it's inherently low. There was a reason for designing, you know, that particular style antenna, symmetrical, in that wide, because it's great for micro pops, right? It's great for short distances. It's great for, let's say you're using Mimosa, right? Where the kind of methodology behind Mimosa is putting as many access points, as many A5Cs as you can throughout a coverage area to really decrease the distances between the clients and the APs themselves. So if that is your end game and that's what you're trying to do, you really need a low gain, wide beam angle antenna, so that way those APs don't interfere with each other, right? So again, use the appropriate gain, the right angle, and the right size for your coverage area and what you're trying to achieve. Again, we have to remember to know where your customers are before you deploy. I've done hundreds now and hundreds of customer deployments, not myself out in the field, but working with WISPs themselves in planning and developing their strategy for deploying their horn antennas. I can't tell you how many times I've gone head to head when saying that customer is not, you know, where it's supposed to be. It should be somewhere else. And they swear up and down. And when you put up the horn, you know, you definitely find out, well, that customer really shouldn't have been there. It was pointed at the back of the antenna, right? They assume because the customer is connected to the north-facing sector that it must be on the north side of that drop on the map, right, where the you know, customer should be facing, right? So know where your customers are before you deploy. It'll help you, again, do the transition and migration a lot more effortlessly and therefore be a lot smoother. Use down tilt as needed to achieve your coverage goals. So again, another, not misconception, but a overused or misunderstanding of particularly our symmetrical horn antennas that have very large elevation cuts, right? So everybody thinks that you know, there's too much gain going out into the air, you're hearing too much of the horizon. So in order, you know, to alleviate that, they use way more down tilt than they need, right? So down tilt is a very important tool. And it's actually, you know, again, one of the biggest tools that you can use in order to achieve your coverage goals when you're using our antennas, but really only use as much as you need. We have a great link calculator on our website. You can drop your customers out in the coverage area and you can adjust 1, 2, 3, 4, 10, up to 20 degrees of down tilt to see how that coverage area is going to change, how the signals are going to change. And in most cases, you either use 0 or somewhere around 5. What I've seen from most customers, if they're using more than 5 degrees of down tilt, it's because they're trying to do something extremely, extremely specific, right? Pointing that antenna very much at a particular coverage area, right? And there's reasons why you would use it, but again, make sure you're using as much as you need based on calculation, not just your own thought that you need more than you actually do. Build balanced networks with horns, right? Again, we give you a whole collection of horns. We have 7 different symmetrical horns from 30 to 90 degrees wide, you know, in 10-degree steps, right? We have now 3 different asymmetrical horns. We have a 30, a 60, and a 90, and we even have our ultra horn, which people are using for, again, very dense, very focused point to multi-point. So when you're building your network, when you're designing your rollout for your coverage area, build a balanced network with our horns, utilize all of those antennas. We didn't create all of them for no reason. They're there to be available to you for your specific needs. So building a balanced network will by far reduce the amount of service calls and overall costs for running your network. Again, the hybrid antenna solution is not the best approach. And it's not the best, I want to be clear, I'm not saying never, it's not the best approach for long term, right? So again, maybe, you know, your customer density never gets there, so maybe you can live with, you know, your traditional sector and our horns at the same time for forever. If that's the case, that's perfectly fine. But just pay attention to your network, pay attention to what's happening. You know, are you getting more and more service calls? Are you all of a sudden seeing more and more noise? If you start seeing that, because you may be in an area right now that you say doesn't have noise or you think doesn't have noise because it's rural, you know, it's probably true. You're looking at your coverage area, you know, but I can tell you with working with customers that if it's not there now, it's coming, right? So you will deal with noise, you will deal with competitors at some point. So if you build your network to be as efficient as possible and as noise resistant as possible from the beginning, you're saving yourself the kind of rebuild later. So pay me now, pay me later kind of methodology, right? And then again, the biggest thing is plan before you deploy. If you look at pretty much everything that I've said here in the conclusion, it's all about planning before you do anything with our horns, right? So know where your customers are, you know, plan what kind of coverage area you want, how far you want to go, find out what kind of down tilt you're going to need to achieve these goals, build or plan based on a balanced network and decide whether you're going to stay at a hybrid solution forever, or are you going to migrate to horns later. If you make that decision from the get-go and you do all that planning, which really doesn't take that much time, it just takes a change in how you do your deployments, you'll be extremely successful migrating to RF element horn antennas from your current noisy side lobe infested sectors. So to wrap it up here, again, I asked you all to join our community, right? So we have a pretty active forum, rfelab.com. It's a great place for you to go and interact not only with us, the RF Elements team, but also many other successful WISPs that are using our technology, many other WISPs that are there for the first time trying to figure out how to solve their problem with our technology. So it's a great place to learn how to use our antennas, and again, interface with a wealth of knowledgeable WISPs and again, the manufacturer themselves in order to get that information. Our YouTube channel is really fantastic. We have a lot of customer feedback. We have a lot of our pre-recorded webinars, educational videos like our Inside Wireless series, which teaches you how antennas work and kind of demystifies some of the black magic behind RF and how antennas work. And again, we have a lot of customer testimonials and interviews. These are coming from the mouth of WISPs themselves and how they utilize our technology and our antennas to help better their WISP or solve some problems that they were having, right? So again, you typically don't want to hear the manufacturer tell you how great their product is. I tell this all the time. We are very honest as far as our product goes, and in a lot of cases, I have WISPs come to me directly and ask, and I tell them, no, this antenna is, this horn or whatever is not going to work for what you're trying to do. We'll let you know, because the last thing we want is, again, to mislead people into thinking that your problem is going to be solved just because it's our horn, and it's not always the case. So again, this is from customers themselves that are out there. So I always say stay tuned. We're just getting started. Our roadmap of products is deep and wide, right? So we have a lot of new products coming down the pipe. There's some that we just announced not too long ago at the WISPapalooza in Vegas in October. Obviously, we have some delays currently because of the manufacturing issues, or the logistics issues, I should say, because of coronavirus. But we're looking at different antenna designs. We're looking at different frequency spectrums. We're looking at revamping some of our older antennas and making them even better. So yeah, we're just getting started. Stay tuned. You can definitely grow with everything that we're doing. Visit our website, rfelements.com. Again, a great first step is to go there and find the answers you're seeking. I mean, really, at RF Elements, we don't just make great antennas, but we also put so much information into the pipeline of our products, how they work, how to use them. So if you have a question about a twist port adapter or a specific horn antenna, go to that product page. Chances are that information is there. Again, rfelab.com, another great place to go and interact with our team and other WISPs like yourselves. And then social media. YouTube is by far one of the best places to go to our RF Elements channel and look at all the videos, pre-recorded webinars, lots of great information there. Social media, facebook.com, /RF Elements. Facebook is probably the best, social media interacting platform to learn information. Even if you're not a big Facebook guy or anti-Facebook, it really could be beneficial for you to maybe not engage with people and talk with them if you don't want, but just go look at, there's a bunch of huge groups that are out there, WISP Talk, WISP Picks, and so many other WISP equipment type user groups with tons of customers from around the world that you can share information with. Again, Google+, LinkedIn, Twitter, you name it, we're there. And with that, I'm ready. This is the end of my presentation. So thank you for joining, and hopefully we have some questions to take now. Okay, so I have a question here. It says, we work in a mountainous area and would benefit from using horns for different customer coverages. Does RF Elements offer planning, help, or tools? So yes to both, right? So you can email us directly at info@rfelements.com. You can reach me on Facebook, Tasos Alexiou. If you haven't seen me on Facebook, you can find me on Facebook. And I can help you, or we can help you direct with some planning. As far as tool goes, if you go to rfelements.com/calc, C-A-L-C, it's our link calculator. So we don't have a RF planner, but we have a link calculator that allows you to do either point-to-point or point-to-multipoint, where you can put out, you know, the pins for where all your customers are on a particular sector. You can pick which horn antenna you want to use or you're thinking about using, put in there, you know, the output power based on your EIRP limit for your region. You can set the MCS, the maximum MCS rate level for whatever radio you're using. So if you're using Prism, that's MCS 9. If you're using LTU, that's MCS 10, or something like EPMP 1000 or 2000, MCS 7, whatever it may be. So you have all those tools there to adjust the settings based on your deployment, and then putting the gain of the CPE that you're using and see what signals you should see. Then you can start playing with down tilt and everything. So there's also some good how to use videos on this calculator page. So go to rfelements.com/calc, C-A-L-C, scroll to the bottom to how to use videos, and then the tool itself. So hopefully that helps. If you have questions, again, you can reach out to us directly, and we'll be happy to work with you one-on-one. So I hope that answers your question. Any other questions?
Please ask all of your questions using the question panel on the right side of your screen, and Tasos will be happy to answer all of your questions. So let's check if we got any other more questions, Tasos. Okay, I think we're done for the questions today, but then also all the information of Tasos and Hasiel will be added at the email that you will be receiving. So if you got any other questions, please email them so we can help you out. Tasos, thank you so much for this awesome webinar. We're really happy to have you. And I think if you don't have anything else to add, I think we're done for the webinar.
Yeah, that's pretty much it. Again, one last time, thank you everybody for making the time today to watch it. I hope it was helpful. Yes, reach out to us directly or EPCOM, either way, to get in touch with us. Everybody stay healthy and stay safe. And thank you again. Bye.
Bye-bye, Tasos. Thank you, and be safe out there. Goodbye. Have a great day.